Hello there, algebra fans. This is Mrs. Lindsay, here to discuss more about the wonderful world of parabolas, specifically AROC, and how the systems of quadratic and linear equations interact. Let's get to it, shall we? So what is average rate of change, and how does it work? Well, with linear functions, we don't really need average rate of change. Our rate of change is constant. The rate of change in a linear function is simply the slope. But quadratic functions and other types of functions as well have what's called average rate of change because their rate of change keeps changing. So the first thing we need to discuss is what interval are we going to find this average rate of change? And in this case, we're going to find it over the interval -1 to 3. So here is our function, f of x equals x squared plus 4x minus 5. And we are going to find the average rate of change over the interval -1 to 3. That's the x's. Okay. Next question is, do we want to find this average rate of change using the formula or the mini table? Well, there are some people that truly prefer the formula. You would have to memorize it. It's not given to you on the reference sheet, but it's simply f of b minus f of a all over b minus a. So in this case, our interval is -1 to 3. So our a is going to be -1 and our b is going to be 3. So we're trying to find f of 3 minus f of -1 all over 3 minus -1. Now, how do we find f of 3 and f of -1? Well, we're simply going to substitute to find f of 3 in for x in the equation. So 3 squared plus 4 times 3 minus 5. And you can use your calculator to do this. This will give you 16. So for f of 3, we're going to substitute 16. If I substitute -1, which is the a, in for x in the equation, on my calculator, I get -8. So there's -8. So f of 3 minus f of 1 is 16 minus -8. And 3 minus 1, or 3 minus -1 rather, is the same as 3 plus 1. So 16 minus -8, 16 plus 8 is 24. And 3 plus 1 is 4. That gives me an AROC of 6. There's my formula. But I think a faster way to do this is using what's called the mini table. And if you have a TI-84 calculator, or in this case I used Desmos, if you type in your y equals x squared plus 4x minus 5 and generate a table, as long as you find the domain over the interval, or the x's, -1, there it is, to 3, there it is. All we need to do is find the change in y and the change in x. Now to find the change in y, we want to decide, how do we get from -8 to 16? Well, let's see. It takes 8 to get just back to 0, plus another 16. That gives us plus 24 to get from -8 to 16. That's my change in y. To find my change in x, I'll do the same thing with the x's. How do I get from -1 to 3? Well, it takes 1 to get just to 0. So it takes plus 4 to get from -1 to 3. So my change in y over change in x is 24 over 4. Well, we already know now that we have an AROC of 24 divided by 4, or 6. A little bit easier, I feel, than the formula, but you choose your method. Now, if you're given a graph, it's even easier. All we have to do is find where x equals -1 to 3 on the graph. So here's where x equals -1 at -1, -8. And here is where x equals 3. That's 3/16. Now we're just going to simply count. First of all, it's from left to right. Always look from left to right. So in the positive direction, we're going to count up from -8 to 16, we know is positive 24. And then always go from left to right. So traveling to the right from -1 to 3 is a positive 4. Again, change in y over change in x. 24 over 4 gives us, again, the same AROC we got from the algebraic method, 6. There's AROC, 3 different methods: formula, mini table, and graph. So this brings us to solving systems of equations, specifically linear equations and quadratic equations. Well, if we're given a linear equation here in y equals mx plus b form, and a quadratic equation, notice it has the x squared. So this is linear, this is quadratic, okay? If we're given both these equations in function form or y equals form, it's pretty simple to just substitute one equation in for y in the other equation. So I'm going to write x squared plus 4 equals 4x plus 1. Now this becomes a quadratic equation, which I can solve using one of the 3 different methods that we've learned. I'm hoping that this may factor, and if it doesn't, after I set it equal to 0, I can simply use the quadratic formula. So I'm going to get rid of the 4x by adding -4x, and notice how there's no like term here for me to add it to, so I kind of put it in the middle. And I'm going to subtract 1 from both sides as well. That is a like term, 4 plus -1. So I end up with x squared minus 4x plus 3 equals 0. Now, I'm hoping this factors, and if it does, since I have a lead coefficient of 1, I should be able to use the add multiply method. So if I have 2 factors, 2 binomial factors, leading with x and x, I want to find 2 numbers that multiply to positive 3 and add to -4. And those are, of course, -3 and -1. I can now tee this up. I have 2 options, x minus 3 equals 0, or x minus 1 equals 0. So x either equals 3 or x equals 1. Now, you may think you're finished, but really you're not. Your solution needs to be 2 ordered pairs. So I know the x of both ordered pairs, but now I need to figure out the y. So the x in both of these ordered pairs are 3 and 1, but I need to find the y. So what I want to do is use the easier equation, and that's usually the linear equation. So I'm going to use the equation where y equals 4x plus 1. And I'm going to sub the answers that I got for x and find y. So if I make x equals 3, y equals 4 times 3, which is of course 12 plus 1, I would get y equals 13. Now I know that when x equals 3, y equals 13. But I would have to do the same when x equals 1. So again, I would use the linear equation because it's easier. I don't have that x squared business. So y equals 4x plus 1. Y equals 4 times 1, which is 4, plus 1. So y equals 5. So when x is 1, y is 5. So here is the solution, algebraically, to the system of equations y equals 4x plus 1, the linear equation, and y equals x squared plus 4, the quadratic equation. If I was asked to graph a system of equations with a linear and a quadratic, I would probably want to start with the quadratic equation, the parabola, and I would probably want to use my TI-84 calculator to generate a table. I should notice that this quadratic equation is concave down because of the negative lead coefficient. And if I generate a table, my vertex will be a max. So for this parabola, I would probably look for my vertex, and remember, my vertex can be found using the axis of symmetry formula, x equals negative b, so negative 2, over 2a times 2 over 2 times 1. So my vertex two times negative 1. So my vertex here is x equals 1. And I would probably graph that first. 1, 2. And then I would graph the 2 points around it. 0, 1, and 2, 1. And then I would graph the 2 points around that until I ran out of space on my graph. Negative 1, negative 2, and 3, negative 2. Now I would do my best to make a nice parabola. And then I would try to graph the linear equation. Now my linear equation, I have a slope if it's in y equals mx plus b form. My slope here is negative 1, and my y-intercept, my b, since my b is 1, my y-intercept is 0, 1. So I'll start at my y-intercept, 0, 1, and what do you know? That's one of the points of intersection. If my slope is negative 1, I'm going to go down 1 to the right 1, down 1 to the right 1, and I'm going to continue until I run out of room, and then I'll go in the opposite direction. So here's my linear function. Now I need to label both. So I'll label the parabola, the quadratic function, y equals negative x squared plus 2x plus 1. And my linear function, y equals negative x plus 1. I find my solutions at the points of intersection, 0, 1, and 3, negative 2. So my solution to this system of quadratic and linear function is 0, 1, and 3, negative 2. This is Mrs. Lindsay signing off. See you tomorrow. Hope you've learned a little bit about parabolas and linear functions.